Okay, so in the last video we have seen this scalar triple product. Now let's come to the second kind of triple product, which is the vector triple product. So of course here we will take the three vector A cross B cross C. Okay, so this is the vector triple product, and the answer that I am writing it directly when I launch the tensor course. In the tensor, using this tensor we can prove this identity. Okay, so what A cross B cross C actually gives is B into A dot C. Okay, so we are taking this the first term of the bracket. Okay, don't remember it as a B and C, remember it as a first term of the bracket B, and multiply with this A dot C. Okay, and then the minus sign. Then we will take the second term in the bracket of the bracket C times A dot B. Okay, so this A dot C is actually a scalar quantity. So it may be a scalar quantity A, it may be a scalar quantity let's say B. So this B times this scalar quantity is just the scalar multiplication, or the multiplication of vector with a scalar, and similarly for C times small b. So and the when we differentiate take the difference of these two, will give a final vector, which is the vector triple product. So a vector triple product finally gives a vector. Okay, so here we can also see that we can also write like this: A cross B bracket over here, and then C. Okay, so what we can do, we can write this like minus of C. We assume this as a vector F, let's say. So the final will be F cross C. So what we are doing, that it is converting into C cross F, but to do that we need to add the minus sign, and then expand this F as A cross B. So the final the expansion of this term will give is the first term of the bracket A into C cross B, C dot B. Similarly minus sign B C A dot C. So here the order does not matter because it is a dot product. So A dot C is equal to the C dot A. And finally this is A C dot B minus sign plus B A dot C. Okay, so similarly we can also rearrange this A, B and C and write the final form. One thing that we have to remember is that when we are expanding this triple vector product into this form, so first thing that we will take the first term of this bracket, which is the B, and then dot product of the rest of the two, minus the second term of the bracket, which is C, and the dot product of the remaining two terms. Okay, so this is a vector triple product. We can prove this identity. Okay, so this identity, we can actually prove this identity. Okay, we can prove this identity, this red mark identity, with the tensor analysis. So when I will start the tensor analysis, I am definitely going to prove this identity. Okay, so what it physically represent? Well, it's hard to interpret at this point of time. What is the physical perspective of this vector triple product? Okay, so I am leaving it now. What the physical interpretation of this vector triple product actually is. Apart from that, we may have the other like the higher product. Okay, so maybe like the 4 vector product, like A cross B dot C cross D. We can have the product of vector product like this. Okay, so how we are going to solve it? Okay, so we can solve it by our previous analysis of this vector triple product and this scalar triple product. Okay, so how we are going to do this? Let's see this. So let's assume this A cross B as some quantity f. Okay, so now it's become f dot C cross D. So we are familiar with this. What is this? This is nothing but the scalar triple product, and we can also rearrange this like this. Okay, so we can just exchange the position of the C to F, F to D, and D to C. So the thing will look like this: D C dot, okay, D cross F. These two are the same. Okay, what we have done, we have changed the position. Okay, so this is the final form, and what we will do after that, we will expand this f, which is nothing but the A cross B, and we know that this is nothing but the vector triple product. So what is its final form? Okay, so the first term in the bracket, which is A, times the rest of the 2, the dot product of the rest of the 2, minus the second term and the dot product of the rest of the 2. Okay, and what is the final form? Which is C dot A times D dot B minus C dot B times D dot A. So in this way we can expand as many a number of vectors, either written in the dot product form or probably cross product form. We can use this two basic rule, which is the vector triple product rule and this scalar triple product rule. With these two things, we can always expand any higher product rule into the simplest form. Okay, so we can also have like this: A cross B cross C cross D. Okay, we can also expand this, and how can we do this? Okay, so there is a way, like what we can do, taking the C cross D as some other quantity, let's say H. So what the final form? A cross B cross H, and this is the scalar triple product. I'm sorry, this is a vector triple product. In the similar way, we'll expand this, and finally I'm writing only the result. You can do on your own. So the final result will be B times A dot B C cross D minus A dot B times C cross D. So this is the final form that you will get after expanding it in this way. Okay, so in the next video I will start the different kinds of vector, like the position vector, displacement vector, separation vector, what are those quantity, and after starting the electrodynamic electrostatic, you will see how these different kinds of vector is going to be useful.